here today to present a vision of 6G, me and my colleagues Ammar and Azeez, and Bilal Omar Akram, and me and Abdullah Dhafer Assan. First and foremost, to be started for mobile communication system, we are trying to follow a pattern here by starting the generation. We are notice that each generation will start after 10 years from its previous one. So for these years, after the 5G has been invented, has been processed in the real life, now many academics and institutions have been processing and searching for the 6G. Just for a brief localization here, geographic area, at European Union, there have been some research projects as a Terraput and Terra Nova and were sponsored by the 5G in phase 1 in 2017. And after that, there will be following by phase 2 and phase 3, aiming to fulfill the innovation of our 6G. In US, following the joint university microelectronic project launched by Defense Advanced Research Project Agency in 2016. China also has been participating in this development with the Chinese Communication Standardization Association. Two study items were launched in 2018. Now, for the main and the requirements and use cases for 6G, these are the main figure which 6G will allow and enhance into these capabilities. In the addition, for higher requirements have been developed for 5G has also been applicable in the real life. Just have found that there is a new requirement to develop and to add and to find and search about to the 6G and have been expanded more widely. The new combination for requirements will be required for the future in new use cases, and these will be explained one by one. The first use case is an extreme high speed and high capacity communication. Through further improvements in communication speed. Let's take an example. By a wireless technology with an extreme high speeds exceeding 100 gigabyte per second, is considered that new sensory services equal to or exceeding actual sensory quality can be actualized. It's anticipated that the user interface that actualizes such a service will evolve as a wearable device through the evolution of glasses-type terminals. Such new experience services will be shared among multiple users in a real time, and the new synchronized applications such as virtual experience and virtual collaboration in cyberspace can be expected. In addition, furthermore, considering such trends as use cases for industry and cyber-physical fusion, various types for real-time information will be required to be transmitted. The AI and clouds, which are the brains, so they need the improvement for the uplink alongside with the downlink performance become more important to use it in 6G. For the second use case, an extreme coverage extension is demanded to enhance and to search. For the future resources, we will aim to develop an extreme coverage extension, and that could be including the sky, the sea, and the space, which are not covered by a current mobile communication system, because basically the more have been produced for the previous 5 generation only been focused on the coverage area on Earth. Through this further explanation for activity environments for humans and machine and the interaction between both of them and the creation of new industries are expected. This expansion is also expected to be applied to future use cases such as flying cars and space travel. The following is an extreme low power consumption and cost reduction. As for 5G, the low power consumption and the cost reduction for our network and terminal devices will be important requirements in 6G from both a business and environmental perspectives. A world in which devices do not need to be charged by is a dream for every user and every consumer in the sixth generation. For example, the development of power supply technology using radio signals is also expected to deal with in 6G. The extreme low latency scenario. In cyber physical fusion wireless communication that connected by an artificial intelligence and devices is analogous to the human nervous system, which transmitted information in order to actualize services in real time and be highly interactive, so that the stable end-to-end and low latency seem to be a basic requirement to handle such a fast information to be transmitted. For the sixth generation, concurrently and approximately 1 microsecond or less than end-to-end latency is considered as the target value to be accomplished in this use case. For example, in a shop automated by robotics, interactive services that respond tentatively similar to a human by watching the facial expression of a customer may be actualized, and based on the facial expression, then the robotics need to be handled, and that will we need to an extreme low latency. For the extreme reliable communication, the 6G are expected to trend toward requiring not only best effort communication, but also quality assurance communication, which that give the consumer and the user a high level from quality of service. Wirelessly communicating highly reliable control information is an important requirement for many industrial use cases such as remote control, factory automation, and so on and so forth. For the 6G is expected to achieve higher levels of reliability and security than 5G. With the popularization of robots and drones and the expansion of radio coverage to the sky and to the whole sky and the earth, there is a possibility that a highly reliable communication is not only limited areas, such as factories, but also wider areas will be required. And actualization of highly reliable communication in nervous scenes is also to be seen in that use case. The extreme massive connectivity and sensing for the wearable user devices and an extremely large number of Internet of Things devices that have been connected, they collect images and sensing information, and the whole database have been gathering and whole the real world are expected to spread further into the 6G era, and an extremely large number of connections that are approximately tenfold, which equals to 10 million devices per square kilometer, more than the 5G requirements are expected. Furthermore, the approach of connecting a large number for the whole Internet of Things devices to a network, the wireless communication network itself is expected to evolve to have functions for sensing the real world, such as positioning and object detection using radio waves. In practical, the study of positioning has already advanced for 5G evolution and is expected that ultra-high precise positioning with the error of several centimeters or less can be achieved in some environments. Now let's bring forward to the research scientific areas. In the previous generation, there was only one representative technology in each generation. However, since 4G, a RAD or radio access technology has comprised a combination of multiple new technologies based on orthogonal frequency division multiplexing. In 6G, the technical fields are thought to become more diversified. This is because the communications quality close to the channel limit has already been achieved by the technology based on OFDM. In a 6G also, a high level requirements will be satisfied through a combination of many technologies has been put in this generation. Furthermore, the definition of 6G RAD also needs to be clarified. The technical fields considered as candidates for the 5G evolution and 6G are outlined next slide. In this slide, we can see the evolution and the progression has been made from the first generation to the sixth generation, and the definition for it, and also the whole combination for the technology and enhancement has been to bring a big gain for the 6G to be expected. For the new network topology and the matter for topology in this network, when ultra high speed also alongside with the high capacity, especially the uplink alongside with the downlink, and improvement the reliability of wireless communication are pursued. It's ideal to communicate at as a close distance and in an abstracted environment, low loss path as possible to that being afford and to generate as many communications paths as possible to increase the path selection candidates. This way can be managed to increase the redundancy. To achieve this, a network topology that is distributed in the space domain is required to fulfill that requirement. In the previous generation, it was only considered an ideal to construct cellular network with a hexagonal cell so that the cells do not interfere with each other. However, in order to increase the path selection, a topology, especially non-orthogonal distributed networks, will be pursued by abandoning the concept of cell and be managing a new concept for distributing the whole total new cell. As we can manage to see here, the topology of such a distributed network is considered to be familiar with the development of high frequency bands, wireless sensing, and wireless power supply. As we can see here, the movement from the coordinated and fixed topology to an as we've seen for the next scientific areas, the coverage extension including a non-terrestrial network can be also be achieved by coverage extension technology is required in order to provide services for the drones, flying car, ships, space stations, and sky travels. Since these services areas such as the sky, the sea, and the space are not fully covered by the conventional cellular networks, therefore the new topology should be examined, the three-dimensional including the vertical direction. Furthermore, a technology that achieves a long-distance wireless transmission over several tens of kilometers is considered to be necessarily mainly on the assumption of the wireless backhaul and IIP applications. HABS has attracted attention again recently because it can stations at a fixed location at an altitude of approximately 20 km. Furthermore, can form a wide coverage area with a cell radius of greater than 50 km on a land. Also have the advantages to providing a backhaul of a portable base stations in a timely and simple manner and of securing independence from land-based communication network, which I'll refer to as public networks. Now, for the coverage extension, including a non-terrestrial networks, the key benefits from hubs can be covered and can be explained in three short words: a coverage, a timeliness, and dedicated. The coverage part is an extreme wide coverage, even the sky, the sea, the remote island. The timeless is the easy deployment of portable base station, and the dedicated part is the independency from public cellular networks. And that each one of them has leading for the how to participate in the 5G and 6G use cases has been shown in this figure. From the wide area coverage including the non-terrestrial networks and the high-speed wireless backhaul for temporary industrial networks and the wide coverage backhaul for non-terrestrial group mobility and, God forbidden, disasters. Now, for the frequency extension and improved spectrum utilization have many importance. So here can be put it into this table, which is between the coverage and the frequency, and can be used to see the phases that have been progressing from the initial 5G and afterwards beyond the 5G and the extreme high data rate and the capacity which can be managed for the 6G. Thank you so much for our